Before we start, we'll give you exactly 30 seconds to try answering this on your own, together with the questions that can be found on the right-hand side of your screen. If you think you need more than 30 seconds, you may pause this video before the start of the discussion. If you think that you don't need the 30 seconds, you may skip this video to the portion of the discussion. Your 30 seconds starts now. Now, let's consider a binomial expression where the operation is minus, or we have here a negative coefficient for the second term in raised to the exponent of 5. So we have a little bit trick here, especially when dealing with negative signs. But of course, let's do it this step by step. And at the same time, please take note of the correct exponentiation. We can start by identifying the n corresponds to the exponent here, so n is equal to 5. After identifying the exponent of this given binomial, let us try to answer this first question. No need to worry about the second and the last question here, as this could only be answered after we are done expanding this. But the first question is essential in understanding the correct process, as this could be a clue to us on the correct coefficients, as we take the number of terms as n plus 1. Therefore, if n is 5, we have here 6 terms. In short, if we are going to expand this given binomial, 2h minus 4k raised to the power of 5, we are expected to have 6 terms. And in connection to that, let us try to come up with the Pascal's triangle with 6 coefficients. Why 6? It's because each of these coefficients will be the coefficient of each of the term in the expansion. We have 1 to 1, 1, 3, 3, 1. So we still have 4, 1, 4, 6. That's 4 and 1. And here are the correct coefficients: 1, 5, 10, 10. You have here 5 and 1. This will be the correct coefficients to be used in expanding this binomial expression. But of course, we cannot automatically say here that 1, 2, 3, 4, 5, the fifth term, its numerical coefficient is 5. No, it's because look at our coefficients. We have, the terms, the coefficients for h and k are no longer equal to 1. So we can structure our expansion in this manner. Hopefully that we have a lot of space here. So we have 1, that's our first. And you have here plus 5. Why do we use plus instead of minus, since where our given here is subtraction? No need to worry about that. Let us simply structure pluses here. And of course, we are going to consider the negative sign as we move further, especially in exponentiation. And if there would be negative signs, it will still prevail than the positive signs here for integers. So let's start. In our previous videos before, we're able to see the pairing of coefficients for the first and the second term following a specific pattern. But here, since we don't have enough space, let us try to solve this at once. But let us be guided with this process. You will have your coefficient for your Pascal's triangle 1, and then the first term, not just h, not just 2, but the 2h itself, will be raised with the highest exponent of 5. And as we move further to the second, third, until the last term, the exponent for 2h will be in decreasing order. As for our second term, we have minus 4k. Please include the negative sign. And 4 in our exponentiation. Okay? But at this time, it's still power to the power of 0, as the exponent of the second term will be in increasing order until we reach here negative 4k raised to the power of 5, which matches the highest degree. Let's try to continue. Again, let's just simply use plus here, times the 2h. Now we'll have the exponent of 4, that's in decreasing order, while the negative 4k will have 1. Okay, as we move further, the first 10, you will have 2h, that's cube, and then your minus 4k will be squared, right? Then we'll have here plus, before we proceed further, you would know that your exponents are correct if you're going to examine their sum. 5 plus 0 is 5, 4 plus 1 is 5, right? 3 plus 2 is 5. If the sum of the exponents matches the highest degree or the n, then you are doing it right. Okay? If it doesn't, then there might be something wrong. So you have 10, 2h, you have here squared, then negative 4k cubed. Hoping that we still have space here, but if we could take the space, then we still have space for the answer here. So 5, your 2h will have 1, while your negative 4k will have an exponent of 4. And finally, plus 1, that's 1 there. Your 2h will be raised to 0, while your negative 4k will be raised to exponent of 5. Okay, so let's apply the exponentiations first. You have here 1, this is also 1, and expression with exponent of 0 is 1. So we'll have here 2 to the power of 5 as we apply here the power law. That's 32h to the power of 5, because it's not just h that is raised to 5, but 2 is included. Here, let's just stick with 5, positive rather. You have 2 raised to the power of 4 is 16h, while here it's still negative 4k, because that's the power of 1, plus 10. 2 cube is 8, so h cube. And by the way, here's my hint earlier. If you see something wrong with the sum of your exponents like this, I missed 4 here, because it should be 4 plus 1, 5. Earlier it was just 8, so it's a sign that it's incorrect. So please also review that process. Negative 4 squared is positive 16. And you will have your k squared. Plus, you will have 10. You have 4h squared times. Here comes the cube of negative 4. That's negative 64 k cubed, right? Plus 5, so we still have 2h, and negative 4, negative 4 raised to the power of 4 is positive, but it would be 16 times 16, that's let's also use calculator if you would like to. You could use calculators here. I do have a calculator here, so let's try to check this. So we have negative 4, okay, raised to the power of 4. That's 256. That's right. You have 256 k to the power of 4. Of course, you have your calculators to use. No need to worry about that. This is also 1. So you have plus. So you have negative 4 raised to the power of 5. So you have here negative 4. Sorry. Let me do it again. Sorry. So we have negative 4 to the power of 5. So 1024. So negative 1024 k to the power of 5, right? Let's stick with the process and answer these questions later. So let's do it step by step. 32h to the power of 5. And here's the change. Earlier it was all pluses, but if you have negative sign here, the signs would have alternating what they call this one, signs. So you have positive, you expect to have negative here because you have 5, okay, 5 times 16 times negative 4, right? So you will have minus 320 h to the power of 4k. Then plus, of course, you will have here 8 times 16 for your third term times 10. So you have 1280 h cubed. Sorry, let's a little bit closer. And k squared. Then here, expect to have negative sign. You will have 4 times, let's just use 64, but of course it's negative, times 10, so minus 2000 rather, 560 h squared k cubed. See what happens to the exponents? 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5. So plus, you will have here, of course that's 10, right? 10 times 256, so 2000, no need for a calculator for this one here, 60 h k to the power of 4, and you will have here finally 1000, negative 1024 k to the power of 5. So this is the entire expansion of our given binomial expression. So it's a little bit longer and trickier, especially if you have negative signs. But of course, don't forget to include the negative sign, including its coefficient in exponentiations and parentheses, so that you could have the correct answer. And of course, you're allowed to use calculators. For the third term, here's our answer. So the entire third term is 1280 h cubed k squared. And for the numerical coefficient, the fifth term, 1, 2, 3, 4, and 5 here. So you have 2560. See, we can only answer questions like this once we're done, but we need to do it step by step. And we use Pascal's triangle here. It only has our exponentiations. So please be guided with that. If you would like to, please share this video to some of your friends who needs this, and also subscribe and comment down your concerns and any other comment you would like to have. Okay, so thank you very much for watching, and goodbye everyone.